negative 4 divided by 2. The first, the x-coordinate, you could leave it like that, or you could write it as 3.5 if you like. And then the y-coordinate is negative 2. So this is the midpoint. Alright, so another type of problem is where under midpoint is where they give you the midpoint and one of the endpoints, and your job is to find the other endpoint. So I drew this scenario right here. So point A would be somewhere around here, negative 5, 6. The midpoint would be about here, 1, 3. And we're looking for the coordinates of this point right here that would make this segment equal to this segment. Okay? Because the midpoint is right there. That's what we're looking for. We're looking for this x and this y. And so just like in class, I'm going to set it up for you the same way. The midpoint, I'm gonna connect the x with the x. So it's going to be, the midpoint is 1 for the x, and I got it by negative 5 plus some number x, we don't know what it is, divided by 2. For the y, it's the 6 with the 3. The 3 is the midpoint coordinate, and we got that midpoint coordinate by adding 6 to some other number y and dividing by 2. Okay? So to solve for x, we're going to multiply both sides by 2. So on the right side, the 2's are gone. 2 divided by 2 is 1. On the left side, I have 2 equals negative 5 plus x. I need x by itself, so I'm going to add 5, add 5. So 7 equals x. Okay, now I move on to the y. Similar thing, I'm going to multiply both sides by 2. 2 and 2 over 2 is gone. 2 times 3 is 6, and then 6 plus y. I need y by itself, so I subtract 6, and I get 0 equals y. So the ordered pair is, or the other endpoint, B, is 7, 0. So that kind of makes sense, right? If we extend it out here, it makes sense that 7 would be somewhere over here, and that B would be somewhere about here. Whoops. Alright, this is from the last handout, worksheet number 22. Number 1, it says find the distance between the 2 points. You can go ahead and sketch them like here, like put them on an XY plane, draw your right triangle and find the distances. Or you can ask yourself, just like I did in the previous section of the video, see how far apart the two x's are. So negative 2 from positive 5 is 7 units apart. And then check to see how far apart the y's are. From negative 2 to 5, that's 7 units apart also. So from A to B, you're going to do the square root of 7 squared plus 7 squared. So that's the square root of 49 plus 49. So that's the square root of 98. Okay? For number 2, you draw, since it's already on a graph, might as well use it, right? We're going to go ahead and draw our right triangle. Okay? So the distance from A to the bottom down to the right angle, that's going to be 5 units. And then from B to the right angle across is going to be 6 units. Okay? So AB is the square root of 5 squared plus 6 squared. So that's going to be the square root of 25 plus 36. Add your numbers together, that's going to be the square root of 61 for AB. Okay? Alright, so they want you guys to determine whether the segments have the same length, so I'm going to highlight them. AB, I got to compare that one with that one. Whoops, all messy. Well, if I draw a right triangle, this would be, let's see, this would be 2 long and this would be 5, right? If I do the same thing with BC, okay, this is 1 and then this is 5. See how the numbers don't match? 5, 2 and 5, 1, they're not going to add up to the same number. So segment AB, so AB does not equal BC. Okay, because 5, 2, 5, 1 are not the same numbers. Then we go to the next one, EF. EF is right here, and GH is right here. Okay, GH is exactly 5 units long. Okay, and when you do the triangle here, this is 3, and this is 1, 2, 3, 4. So for EF, when you do the 3 squared plus 4 squared, that's going to be 9 plus 16 square root. That's 25. So the square root of 25 is 5, right? So 5 equals 5. So yes, right here, EF does equal GH. Okay, we already did 4. Number 5, it says DE has endpoints -1, 6, and E, 3, -2. Then the midpoint M of segment DE lies in quadrant 1. Okay, for a point to lie in quadrant 1, both X and Y have to be positive, right? Because here's quadrant 1, everything in here has to have positive coordinates. Okay, everything is positive here. When you add 3 plus, I'm going to add this one with this one. Remember, for midpoint, you add the x's together. So the midpoint, -1 plus 3 divided by 2. And then you add the y's together. So 6 plus -2 divided by 2. So that's going to give me 3 minus 1 is 2. 2 divided by 2. And then 6 minus 2 is 4. So the midpoint is 1, 2. So yes, 1, 2 is in quadrant 1. Okay, for number 6, we want to see if JK and LN have the same midpoint. Okay, so JK, we have, I'll circle it right here. Here's J and here's K. So we're going to add for the midpoint of that one, midpoint of JK. It's going to be -2 plus 6. Remember the average of the x's. And then I'm going to take the y's. 3 plus 5. So 6 minus 2 is 4. 4 divided by 2 is 2. 3 plus 5 is 8. 8 divided by 2 is 4. So this is the midpoint of JK. Now the midpoint of LN. So L has x's 0 and 4. So the midpoint of LN. LN. So it's going to be 0 plus 4 divided by 2. And then I look at the y's. 7 plus 1 divided by 2. So 4 divided by 2 and 8 divided by 2. And yes, they give me 2, 4. So this is yes. Okay, so number 7, we're looking at the figure above the plane. Plane that has points H, K, G, and I on it. And point L is out in space. It's not on the plane. It says list 3 non-collinear points. Remember, non-collinear means that they're not on the same line. Collinear means they are on the same line. But right now we're looking for non-collinear. Okay, that's the key right there, non-collinear. So 3 points that are not on the same line. I could say, hold on, let me erase the board a little bit. Okay, so I could say, there's several combinations. I could say H, point H, K, G. These are 3 points that are not collinear. Or H, L, G. Those are not collinear. Or I, G, H. Those are not collinear. Okay? And there's a couple more, but I mean, those are just some examples. Now for number 8, list 3 coplanar points. So coplanar means that they are on the same plane. So H, K, G, or I could say, because it wants 3, right? Or I could say I, G, H. They're on the same plane. And even I, G, K, they are collinear, but they're also coplanar. Okay? Name a pair of opposite rays. So remember, opposite rays are going opposite direction. The word says it. And the order does matter. How you name the ray does matter. So I'm going to look at the line right here, line KI, and I'm going to get the opposite rays from there. So ray GK. Oops. So the arrow goes to the right. Even though on the picture it might not go to the right, we always draw the arrow to the right. And then the other one, the opposite, so GK and GI. Those are opposite rays. Okay, number 10 is KG, is ray KG the same as ray KI? So look up here at the drawing. Is KG going this way the same as KI? Yes, it is, because it starts, both of the rays start at K and they're going in the same direction, so the answer is yes. Alright, so this one came out a little blurry, but you guys have your own paper, right? So 11, name a point that is collinear with points G and H. Collinear, remember, points that lie on the same line. So point G is right here, point H is right here, so the only point that's collinear to the 2 points would be this one, and this would be point F. Okay, number 12, name a point that is coplanar. Again, coplanar are points that are on the same plane. So A, D, and E. So A is right here, D is right here, and E is right here. The only other point that's on that same flat surface would be this one right here. I believe it's H. Let me just check my paper. Yeah, it's H. Okay. Now, number 13. H, J, and K are collinear points. Okay, collinear points. So I've got one here, one here, one here. With J between H and K. Okay? That's important that you put them in the right order. If HK, so from here to here, HK is 21, JK is 7, find the length of HJ. They're asking for this one. So remember, HJ plus JK equals the whole length, HK. So this segment plus this segment length will give me the whole segment's length. So that's this equation right here. So it's going to be HJ, we don't know, so we'll just put HJ for now. JK is 7 and HK is 21. So I'm going to subtract 7. So HJ is 14. So right here, that's 14. Right, A, B, C are collinear points. So, sorry, I don't have the pen on. So you have 3 points on the same line, collinear, with B between A and C. So I have B between A and C. If AB is 9, so this is 9 from here to here, and CB is 7 from here to here, find the length of AC, of the whole segment. So then 9 plus 7 would be the whole segment, right? So that would be 16. 9 plus 7. Okay, in the diagram of collinear points, LP is 33, so it's 33